A very good evening to you and welcome to Kaizen Central from Manufacturing TV. A delight, as always, to see so many people joining us on the call this evening. I'm really pleased to say that we've got quite an unusual story for us here at Kaizen, actually, to talk about production line matters in quite granular detail. But Andy Dorset, he's Associate Director of R&D at Procter & Gamble, has got what I think is a very interesting story that, to me, represents the confluence between process manufacturing, digital manufacturing of the future revolution, 4.0 revolution, and of course the drive towards carbon net zero. Andy, very good evening to you. How are you?
I'm very well, thanks, Nick. Good to be here. Good to meet you all.
Superb. Well, Andy, perhaps I could ask you just to start off by telling us what it is you're doing at P&G with this project, the Argus project, who's involved and what you're hoping to gain from it.
Yeah, sure. I mean, a little bit about me. I mean, I've been 30 plus years at P&G. I've worked in manufacturing, I've worked in R&D, most of my career in R&D, and I'm now working on quality innovation. And a lot of the focus we're working on at the moment is how to assure the quality of our products, but without taking samples to the laboratory to dissolve them up and test them with traditional wet chemistry or traditional techniques for confirming the quality of the product. So we've been looking at, and coming straight to Argus to the point, we've been looking for opportunities to address one of the biggest challenges we have on some of our consumer good products, which is related to the area of testing microbiology. Because clearly what we don't want is micro-contaminated products going on shelf to consumers. And we obviously want to protect not only the consumers, our customers, but also our employees when we're producing these products. The traditional way of doing that is a very laborious test where you take a very small sample of the liquid, spread it on an agar plate, wait a couple of days, and if it grows something, then you've got a problem to deal with, and if it doesn't grow anything, then at least you're good to go. But it's a very laborious test to do. Hasn't really been developed any further as a test method for many years. So we saw an opportunity there to say, well, is there a different way to assure the quality of the product by leveraging the external world? And actually, we explored an opportunity through Innovate UK, through the Manufacturing Made Smarter competition about a year ago now. And the idea of that competition was very much in line with what we're looking at internally, which was to create an innovative digital solution to solve a real life end-to-end supply chain problem. So our end-to-end supply chain problem, or challenge, if you like, is how we can assure the microbial health of the products that we produce end-to-end, from our supply chain, starting with the raw material all the way through to the finished product and the export transportation that we use, and how we could do that by measuring two things: measuring microbiology in line real time, and measuring the formation of biofilms, which are also another indication that you've got a problem in your system, by looking at sensors that could detect the creation of biofilms that would give you, an indication of what was going on. So we created a consortium of 3 companies, one academic, University of York, who have a particular know-how in the field of measuring microbiology by very, I would call it, novel techniques. We worked also with some contractors and did some external research to find some sensors that can measure and detect biofilm. And we also connected with one of our upstream suppliers, which is Libra Specialty Chemicals in Manchester, who make one of the key raw materials for the supply chain that we're looking at in the UK, which is actually the Fairy Liquid supply chain that we have based at our London plant. So the idea of the consortium was to create a feasibility study, for which we're currently halfway through, in fact, exactly halfway through, started in April, ends in September, where we are trying to prove the concept that we can actually measure and detect inline microbiology detection, both for creation of microbes and creation of biofilms, using the York technology and some of the biofilm sensors that we're using. And in addition to that, we're trying to create a digital solution to capture the data from these sensors, to bring it to a central repository, such that we can create a digital, call it certificate of analysis or health check of the end-to-end system. And also we're looking to create some models to actually, over time, integrate not only the micro data, but also the in-process data, and probably using artificial intelligence to actually model and predict what's happening in the microbial health of our supply chain. So in a nutshell, hopefully that's clear, stop me if it isn't, that's what we submitted to Innovate UK. They like the idea. We know it's fairly novel because we know no one is making those type of sensors in the industry today. And we were granted a feasibility study to which we're now, as I say, halfway through at the moment.
What's the definition of success at the end of the study, Andy? Obviously, it's not going to be a finished product, but what would you take as the mark of success? What will make you happy?
So at the end of, so you mean for the feasibility study, or you mean overall?
Yeah, no, the feasibility study first of all.
Yeah, the feasibility study is really kind of focusing on proof of concept. So it's basic. So we're basically building a little test rig that we will, locate the different sensors in this test rig. We will pump the liquid that we're interested to test around the test rig, and we will inoculate it with bacteria so that we can overload the system with bacteria, such that we will then assess the sensors in terms of their ability to both detect and be able to measure the amount of bacteria that's being produced in that test rig. And from that, so that's what success looks like. And the success on the digital solution is that we can capture data from those sensors on this test rig, such that we can prove digitally that we can capture the data from the sensors and be able to integrate the data with our process information as well.
From the sound of it, in pure production efficiency terms, assuming all goes to plan and this becomes sort of just day-to-day technology used by P&G and eventually by everybody else, I guess, this takes days out of the supply chain operation for you, doesn't it?
No, absolutely. So in terms of the benefits, indeed, the reason we're doing this is one, for agility. So really to help speed up the supply chain. So indeed, eliminating these checks or tests that take several days, where you're holding finished product inventory in warehouses, or you're holding up tank cars before you unload them. It's also, we hope, also going to enable us to optimize some of the preservatives that we use in the system, because today, obviously, the one way to protect consumers is to put something into the product that will deal with any microbial growth. Some of those materials, obviously, we would like to reduce and even eliminate. So if we actually have a real-time assessment of what's happening in the process, and we can build that digital data using AI and develop that through a model, we've then got a much better idea to predict what's happening to the microbial health, and also adjust the level of preservative that we may need in the future. The other benefits are we spend a lot of time on things like cleaning and sanitizing, not only the process, but also the tank cars that are used to truck the materials and the finished product around. And that's a lot of water, a lot of heat. That again, we're looking to see how we can either reduce or optimize that, such that we only do it when the sensors tell us you need to do it, rather than we just do it religiously every time we do a change. So from a sustainability standpoint, the reduction in water, the reduction in heat needed to do that is obviously quite big, both for us as well as Libra Chemicals, who are dealing with the same issue.
And we're talking here about products such as detergents, shampoos, washing up liquid, cosmetics, that sort of thing. This is not food. This is chemical products that we would use every day in the home. Yeah,
the primary focus is indeed on sort of home care or personal care products. But actually, part of the remit and part of the reason I think we got the funding from Innovate UK was we're looking beyond our own business. So we do see this has the potential to go into other industries, whether that's food and beverage, whether that's pharma, whether that's paints and coatings, whether it anything that has a microbial risk associated with it. We do see that there are benefits beyond our own, industry where this could be reapplied.
And is there a possibility that, I mean, I did read part of the Argus introduction. There's a suggestion that it may enable you to use different, more sustainable products as the sensors become ever more reliable. It gives you greater margins to replace some of your products with something that's a bit more sustainable?
Yeah, that's true. We use a lot of synthetic chemistry, but if we can move to more naturally based chemistry, then indeed that offers up different opportunities in terms of how we formulate in the future. And of course, from an environmental or sustainability footprint point of view, then indeed that's a much better place to be if we can get there. We do use some natural materials today, and indeed they have the same microbiology challenges as some of the synthetic ones. That any water-based system is potentially going to be at risk. So, but indeed it will allow us to use more naturally based raw materials in the future as well.
So I suppose, just to sum up, it feels to me like the way it's currently done, you have to take a sort of almost 110% approach to cleanliness right around the production and the transportation, because otherwise you'd have to test every inch of the way. And this means that actually, as long as the sensors say you're clear, it adds so much more efficiency to the whole process.
Yeah, it does. I mean, just to put it into context, some of the numbers that we looked at for ourselves in terms of the micro checks that we do, which is on the product, in the process, some of the micro daily management that we have to do. I mean, we probably do about 800,000 micro checks a year. So that's a lot of micro testing, and we have a lot of microbiologists. And that, and the cost associated with that, even just for our business, is in the millions every year, as well as the cost of hiring the people to do it. So it is a lot. So if we can reduce those number of tests significantly through using inline sensors that can give us a reliable data point, then indeed those savings are going to be very big.
How's the challenge for SMEs to get involved with gone? I mean, are you getting the input from the SME sector, and what are you looking for?
No, that's a great question, Nick, actually. And one of the things that we clearly see is, I mean, right now we're in a feasibility study. We've just approached Innovate UK and confirmed we want to continue the project and go for there's another phase of a 2-year industrial research program. So that allows us to extend the project, but also allows us to bring in other partners, to the program, because there are clearly some things that we need to scale up. So, as I said earlier, the feasibility study is just to prove the concept that this can work. But the 2-year industrial research is we need to prove that this can work in our end-to-end supply chain, both at P&G and also at Libra. So that will involve us needing to scale up some of the know-how at York University into physical sensors that can survive the sort of industrial processes that we need to they need to be employed in. We also then need to link the digital signals from those sensors into a web app that we're creating at the minute. So there may be some additional work there, but I think from an SME standpoint, creating the sensors is probably the biggest need that we have at the moment. And although University of York have some excellent know-how, they don't have much insight into how to scale up and produce a physical sensor that we can use in a plant. So we are looking, and in fact, we've reached out already. And in fact, I see Ram on the call. I mean, we've already had a great, hey Ram, we've already had a great connection with Ram and some of the work that I know he's doing. We've also reached out to the KTN via Innovate UK. We've also reached out to Confer, who try and match up university research with SME companies in terms of what's the best fit for the problem that you're actually trying to solve. We've involved several of the catapults, the CSA one, Nick, that you gave to us, which has also led to an interesting connection. And also we're talking to people like CPI, so the manufacturing catapult in the northeast of England. So right now we're just in the process of activating and sort of broadening our sort of brainstorming portfolio, if you like, in terms of who are the right partners that we want to work with here. Ultimately, this will be something as a consortium we need to agree with York, because it's their know-how, it's their IP, and obviously whoever they choose to finally work with, that's something that they're going to have to get clear going forward, because we hope, obviously, that they can scale up the science into a sensor. And obviously, we hope that's going to turn into a business for that SME.
What's the mechanism, Andy, just in case anybody here is either wants to get involved or knows somebody who does? Is there a web page or a link, or do they email you? How do they do it?
Probably the easiest way is to get in contact with me directly. I'm the sponsor of the Argus program on behalf of the consortium. I'm basically filtering all of the different, contacts that we've got out at the moment. So indeed, if anyone is interested to get in touch or thinks that they can help the consortium or wants to learn more about what we're doing in the consortium, I'm very happy to handle that on a one-on-one basis, no problem.
Well, that's brilliant. Now then, let's see some hands. Who wants to talk to Andy about some of the challenges and maybe have some input themselves? Niraj.
Hi, Andy. Thanks, Nick. So the challenge that you have explained, it's indeed, it makes so much of sense. And obviously the upside for not just the FMCG, but a whole lot of other sectors could be massive. There have been similar experiments or similar researches happen in detecting microbial things in water, and also there is some precedence, but obviously there is not a finished product or a sensor that could detect to the level that you want, especially with challenges that are there in given the size of the micro organisms. But the good thing is that there are people available who specialize in microbiology, and there are people available who specialize in sensors. And the idea is to try and put those together. And because specifically I worked on projects wherein we delivered sensors, though for something else. involving people like from the Indian Institute of Management and Indian Institute of Science. So those I've been personally involved in. So I would be keen to get some more details. Obviously, I have been talking to Ram for a long time, but we'll try to get some more details to see if there is something that I can bring to you in terms of a possible solution or a collaboration. We'll be very happy to look into that.
Okay, thank you, Niraj.
Thanks, Niraj. Steve Murphy, yeah, I thought you put your hand up. Yeah.
Yeah. So I come from a semiconductor background, Andy, quite a lot. And bugs were a real problem when I was a lad, when we were dealing with, technologies at 3,000 nanometers. And now they're down in the 5 nanometer range. I can imagine bugs are a big problem to them. But yeah. I've never seen anything of what they do nowadays to actually control bugs. So in terms of system design, system monitoring, I was just wondering if you'd spoken to anybody from that real high end of the semiconductor industry to see if they already had some novel solutions.
I haven't talked to anyone directly in the semiconductor industry about that. And could you say a bit more about what exactly they could offer in that regard?
Okay, well, when you work a lot maybe with deionized water, which is an extreme case because bugs just love it, you have to go into a lot of detail about system design and valve design, so you don't have dead spots and things like that. So Sorry, go ahead. So my point was that's your basic system design, and now what I don't know is how if some of the really high end fabs are dealing with, say, 5 nanometers, sort of what's that, about 25 silicon atoms long, have got some other ways of dealing with bugs, because I don't know. I'll have a look and see if I can find somebody who might know. But it does sound an area where they might have something already, but they might be very quiet about it.
It's possible. I mean, it's interesting what you say. I mean, in terms of how we deal with bugs, I mean, you talked about the right design of valves and pipes and surface finishes. I mean, that's actually another challenge, but equally another opportunity, which is, we have clean design standards within P&G, and that's all around how you design tanks, pipes, valves. What are the surface finishes that you need on those pipes to avoid, as you say, 5 nanometer bacteria just sitting on the pipe and then growing and creating a biofilm, which is a real challenge for the process. But it also goes into things like, when you're cleaning and sanitizing, what's the right velocity of water that you need to have going through the system to flush residues, and equally when you're putting hot water through, how long do you need to heat it for to remove the biofilm, and how do you know that biofilm is completely gone when you've done it? So indeed, there's a lot of know-how we have in that area already. But again, the sensor is probably the most interesting thing in terms of, well, how do you know it's clean? And can that sensor even survive that cleaning and sanitization process such that, it's we don't have to keep replacing it every 5 minutes?
Yeah. Okay. Thank you,
no, very helpful, Stephen. Thank you.
Well, I'll talk to a couple of people and see if there's the worst that can happen is they don't know anything, and that's not the end of the world. 5 minutes.
I think you'll find. I mean, we've done. It's interesting what you say. I mean, in the area of certainly sensors for measuring microbes in a fluid flow, I would say there's nothing out there today. And we've done a lot of research in that particular area. In the area of biofilm, it's different. So I think, Niraj, you mentioned water, and in fact, one of the sensors we're testing in the feasibility study is a sensor from the water industry to measure biofilm in water systems based on ultrasonics. And that works very well in water, but equally we're now testing if it works in the chemistry that we want to use given the pH and the viscosity of the liquids that we're using.
Right. Did I see any more hands going up? Right. I'm wondering what the implications are long term. Did you suggest earlier on, Andy, that this might be applicable to food? Are you saying that's why the government was happy to put some cash behind it?
Yeah, I mean, I think the reason we got the funding, I think, was that it has cross-industry appeal, and there is reapplication potential. Food and beverage is one, pharma is another, paints and coatings is another. I think there's other industries out there that I think could certainly benefit from that. And we've done quite a bit of, before we even started on this project, we did a lot of extensive benchmarking with other industries, non-competing industries, around how they deal with microbiology. And we're all dealing with the same problem, using very similar methods and similar chemical preservatives to control microbial growth in liquid products. So we know that at least the project has some appeal from that sense, because if we can get it to work and we can then reapply that to other industries, one, that's going to help indeed UK PLC. It will also help, we hope, the SME in terms of scaling up, making, producing and selling sensors in a completely new field, which doesn't exist today.
Stephen Barr, good evening.
Good evening, and hi Andy. That's really interesting stuff at the technical level, and particularly just the level of benefits that you seem to be predicting for the partners in the project and the wider industry too. I've got a question really about the, I suppose, the funding and the way that UKRI and others go about checking that funding goes in the right direction. I just wondered if you had any comments on the challenges you had at the bidding stage of convincing UKRI that the benefits would be worth going after. And I suppose a second subsidiary question is around, well, if the benefits are so high, did you have any challenges around actually convincing them that public funding was appropriate for the project?
That's a very good question. Indeed, the bidding process was quite an arduous one. In fact, what we did for the feasibility study, it was about this time last year that we really started in earnest. And we probably spent a good couple of months, first of all, assembling the partners, getting the problem statements clear, and then really starting to write the draft for Innovate UK. And they have a very clear pro forma that you need to meet with a set of 10 questions that you need to fill with no more than about 500 words, if I remember rightly. So you need to be concise enough to make sure they understand what you're talking about, but equally compelling enough that they're going to fund you. And I would say one of the things that we chose to do at the time was we actually had our application peer reviewed by Pricewaterhouse, who have a particular division that can help on bid writing like that. So we wanted to make sure that indeed how we were positioning and answering the questions was likely to be appealing to Innovate UK. So we spent a little bit of money to have it peer reviewed. We got a lot of good feedback on that in terms of how to either adjust or modify the text in terms of how we wanted to present the problem. And indeed, one of the questions is why should public money be spent on this? And the real reason behind that was many of the reasons that I mentioned earlier, but also the fact that what Innovate UK were really looking for was how this can create either new industries, new roles, reapplication beyond your own industry, whereby if we hadn't have created the consortium, we probably wouldn't have had it funded. So we didn't ask for a huge amount of money. In fact, the only money we asked for was the out-of-pocket costs for a PhD student or two at York, and several subcontractors for the sensors that we want to test, and a little bit of out-of-pocket spending, and the rest of it is our time. So we're putting our own time into the project, and that's basically how we balance the books with Innovate UK. But I think the big hook was the fact that this would travel beyond P&G. If it was just for P&G, they would never have funded it, and why should they? In fact, I would never have applied if I thought this was only going to work for P&G. But then when we talked to Libra, when we talked to York, and we saw the possibilities, in fact, the other point is it also can go into broader chemical industry as well, not just the consumer goods that I mentioned. And that's where Libra were also very interested. So I think that was the big hook for Innovate UK, the fact that this would travel beyond just one company or two companies, and why it was worth funding, and the fact that the technology solution does not exist today. The problem is a real one and exists in many different industries. And if we can crack it, this could be unique benefit, let's say, for the UK.
Yeah, I think your point about collaborative benefits is really spot on. That does seem to be a way of spreading the benefits across the economy, and yeah, it's good. But as a Innovate UK assessor, which I've been a few times, I was probably super harsh on companies who appeared to have deep pockets, but where they show collaboration, that's really very attractive. Yeah, I think we've all got a lot to learn from that in terms of public funding access.
Okay, thank you, Stephen.
I find it interesting, going back to the CSA catapult, Andy, that I put you in touch with, that catapult was developed with the express intention of taking the expertise that exists in the South Wales cluster, are based really around IQE, which makes compound semiconductors, and is a world leader in compound semiconductors. But all the applications, all the high value that derives from those semiconductors is being made overseas. And the idea was to try and encourage the CSA applications catapult, was designed to find businesses, encourage businesses to get into making applications using homegrown technology and having homegrown added value. It seems to me that this has a similar feel to it, that there's a technology opportunity, and we're looking for smaller, adventurous, high-tech manufacturing engineering companies to get involved and build a whole new business stream.
Yes, no, exactly. That's exactly what we hope to achieve. And indeed, I think that's certainly what inspired me, and certainly the rest of the consortium feel very good about that. And I think York now, who are beginning to realise that the progress they've made with the science so far looks very good. They're now getting a lot more interested in, wow, how can we turn this into a business opportunity beyond, which is exactly what we're trying to do anyway as part of Argus Consortium. So I think it's also opened their minds to all of these possibilities. But indeed, the challenge is who's the right partner to work with, because I think that's the big unknown for us. Certainly in P&G, I don't have that knowledge and experience, and I think a lot of the catapults and KTMs and some of the other external networks that we've employed, including talking to yourself and Ram, who's been super helpful. I think is really opening our eyes to new and different possibilities. And we certainly haven't got the answers yet. So, I mean, I'm very open to any other input or any other ideas that people have on this. And part of the reason I'm talking here tonight to you all was at Nick and Ram's invitation, but also, this is not just a P&G private product. This is project, this is something that we want to, we want to succeed in, not only for ourselves, but also that we can indeed create those new industries, create those new technologies, and hopefully make a new industry out of it.
Super. Ewan, you've got your hand up. Good evening to you.
Yes, good evening, and thank you very much, and thank you, Andy. Forgive me, I won't put the camera on just because I'm out and about, so the reception's not great. But no, really interesting. And I guess, as somebody who has recently got involved in a sort of an SME involved in sort of, automation and test and detection and the like, just really understanding, you've talked about the importance or the fact that you've been looking across the SME space, particularly focused on the sensors, but, are there other opportunities, let's say once with the development of sensors to then incorporate them or automate the process, and what other opportunities do you think are available, given that you're talking about potentially creating a new industry for different types of SMEs?
Yeah, that's a great question, Ewan. I think the immediate opportunity is definitely in turning, some of the novel techniques at York into a physical sensor. So that's our most immediate need. And that may crop up in both areas, both in the microbial detection in a fluid flow, as well as the biofilm detection. So there's potentially two different sensors that we need to create. I think the other area may be in the area of sort of the digital solution, even, because one of the big challenges that I see is we're creating a bit of a web app, but that web app needs to connect to not only the existing digital architecture that's sitting in P&G and also at Libra, but also needs to connect on the other side to these sensors. And that's not an easy problem to solve. And there may be industry solutions out there, or SMEs that are already working in that space, who maybe have solved those sort of IT/digital solutions in a smart way. So right now we have a data scientist who's part of the project, who's actually helping create the web app and make all the connections, to the internal and the internal connections and the external sensors. And we're kind of learning that from ground zero. Now we're making good progress, I think, but on the other hand, could we benefit and could we learn more and faster from others who are already working in that space? I mean, that's a conversation that we've started to have as a consortium as we think about the 2-year industrial research phase that we want to apply for. But it's really those. So indeed, there's a couple of opportunities for sensor development and creation, and then possibly the IT solution eventually. And we need to give that one a little bit more thought. But equally, in that area, I would say I don't know what I don't know. And at the end of the day, if we have to build it ourselves, we'll build it ourselves. But again, if this needs to travel to other industries, we need to make sure that the digital solution can connect with any other internal system through an API or through whatever databases we choose to use.
Thanks, Andy. Steve Murphy.
By digital solution, Andy, do you mean collecting all the data that's coming from the sensors, and then putting it into some sort of giant database, and then processing it with some sort of learning algorithm or something? Yeah. Which says, when number 27 rises to 14 ferrets, we need to get the cleaning organised for the weekend, sort of thing. Yeah.
You got it.
Well, I mean that sort of big data collection is, I understand, to be fairly common. It's I know people running it. I would have thought the basic collection and putting it into the system was, I don't know, it sounds sort of routine to me, to be quite honest.
I think that's a fair point, Steve, because we have a database that we're going to put all the data in. We have other digital architecture that we're connecting up to make data flow from Libra to P&G, and then from P&G within the internal systems, and indeed going to this database. So we have a solution today. The question is, if we want that to travel, is there any benefit from, and I don't know what the answer is, is that just something that we package up as a web app, and then it's up to other industries and other companies how they connect that to their internal digital architecture, or is that something that an IT solution SME could help us with? I don't know. I don't know what the answer is on that one.
Andy, I wonder if I could ask you about, in a sense, it sort of follows on from Steve's question to an extent, but you mentioned AI. Obviously, you want these systems to learn as they go along. Can you just describe the kind of the level of artificial intelligence you're looking to get deployed in this?
Yeah, I mean, what we're looking to do is kind of integrate our process data, our raw material data, and the micro data from the sensors all coming together in a database. By looking at the real-time changes in that data, and by real time, we've also got a bit of a challenge in terms of, well, what is real time when you're trying to measure microbiology? Because it doesn't happen in milliseconds, it happens in hours and sometimes days. And also the supply chain is a little bit, disconnected in some regards. So what we're looking at is integrating all of that data into the database and using artificial intelligence to look for trends and changes in either the micro data linked to the process data, such that we can make, as Steve was saying, better prediction on when to go in and clean and sanitize, when to hold the product to do some additional testing if we've got an alarm that's showing that we need to go and do some testing on, for example. It's about that self-learning over time based on multiple, let's call it purchase orders or production runs that we do for Fairy Liquid. But over time, we can then learn and adapt our processes and our procedures to make sure that indeed we intervene in time before we end up with an issue, and that we obviously need to go and validate that as well. So that's the sort of thing we're looking for AI to help us learn over time when to make interventions into the process, when to make interventions in the product, and when to do nothing and let it flow, which is obviously what we're trying to do every day.
You mentioned that in IP terms, the center of gravity at the moment is with the University of York, and they obviously do quite well from this, assuming everything goes according to plan. But the real business opportunities are also with these, whoever comes up with perhaps the data management for you, whoever comes up with the sensors. I mean, this could be very, very exciting financially.
It could be, and from an IP standpoint, I mean, obviously York brought a lot of IP with them before we, into the consortium. So a lot of the know-how is with them. We've obviously created an IP agreement across the consortium to make sure that York's interests are protected and our interests are protected. I mean, as far as the IP and the sensor goes, I mean, that's really with York. So that's not anything that P&G is interested in. But what we are interested in is the application and the benefits that it brings by using those sensors with that level of know-how. So we will protect the application of using the sensors in our process. York will have the know-how on the actual science behind the sensor, and I'm sure the SME, whoever comes in, will also want to protect the sensor itself so that they can obviously get the royalties and the licensing and protection that they would need, in order to grow their business sustainably.
I'm going to put Mark Weymouth on the spot simply because he's a sensor kind of guy. Mark, does these kind of sensors, is anything that you run across or have run across?
It's a different area to the area I'm in because I'm predominantly proximity sensors, but the scope of the mass data analysis is typical and becoming ever more affordable. So it sounds like something that could offer phenomenal payback and phenomenal scalability to lots of different applications.
Right. Yeah. That's sorry. I did put you on the spot there. I do apologize. Needing people to put their hands up. Come on, guys. I'm an old journalist, but I run out of questions eventually. Ram, I rely on you. There you go. Good evening, Ram.
Good evening, everybody. Hello, Andy. Good to see you again. Hope you
had a good to see you too, Ram.
Yeah. So yeah, I mean, I've literally put my hand up to say hello, nothing more, because everything we've told everybody here, I'm kind of privy to all this information given how much we've spoken. So it's more about giving you a reassurance that this is perhaps one of the best connected and most helpful groups I've bumped into in all my years of being in the sector. So if there's any help you might get, this is probably has a bigger or a higher probability of finding the help you need. But again, we still need to talk, and we will hopefully have a date in the calendar soon. But so some of the best minds in the country, for example, in the sector are right here. So good luck. So
no, absolutely, thank you.
Now, so yeah.
Well, we'll have a whip round later, Ram, and the check will be in the post, Ram. It's okay. Good man. Thank you for those kind words on behalf of the gang. Richard, good evening to you.
Good evening. Yes, I'm sitting in the background, not 100% sure. Another company in Rochdale, smashing it, which is Aquacheck, they do a lot of water testing, and they've managed to have sensors to be able to find lead and find what type of lead, where it's come from the brass. And everyone's looking at them going, how have you done this? You're years ahead. They've even come up with a barrier that I've got a sample here. This stays on the hand for at least 24 hours, and it kills all viruses as well as bacteria. But once again, it's how do you get it to market and all the tests and checks that it has to do. So they're putting that through as a cosmetic rather than the hospital side. That guy, I'm going to try and connect you to, and hopefully he might know something, because they work with Manchester University very much on the sensor sides, and I don't know if picking out specific elements and chemicals is they going to be the same as picking out microbes, but they have managed to do it to the extent that sort of like the US military are sort of saying we need to know about this, because they've got the same issue over water and filtration and what's in that water, which is what's in a fluid as it's moving through. So hopefully I might be able to come back to you. I think the main one is Procter & Gamble, fantastic company, absolutely awesome. Large companies do struggle to obviously challenge someone like the Crystal Doors, which is tiny, and we can turn on the spot and we can shoot off. Procter & Gamble's attitudes towards marketing is you're constantly testing, you're constantly looking for new, you're constantly trying to push the boundaries. Very impressed and great talk. Thank you very much, Andy.
Well, thank you, Richard. Appreciate that. And actually, interesting what you mentioned. One of the techniques that we've been working with York, which hasn't kind of worked so well so far, is bacteria secretes chemistry into the fluid, and it's typically tryptophan, which is apparently quite a difficult thing to measure. So I don't know whether this company would know. I mean, you're talking about lead and other mineral deposits, I guess, in water, but this is more kind of it's organic chemistry basically. I mean, but tryptophan is one of the byproducts of many of the bacteria that secrete in water, and measuring that is, well, one, it's very, very low level in the fluid, and secondly, it's quite difficult to measure, and we haven't quite figured that one out yet. So we're almost at the point of giving up on that idea. But again, I'm open to any possibilities that could help us, keep going on that idea, and different techniques may give us different solutions. So thank you for that.
Thanks, Richard. Yeah, I thought tryptophan was something you got when you ate bananas, or is that? Am I not right? That with warm milk, or I was always told warm milk bananas, it releases a chemical in the human body called tryptophan or something, calms you down.
Could well be, Nick. I couldn't honestly tell you.
Hey, listen, I'm going so far beyond my level of competence at this stage of the game. that I should ignore absolutely what I have to say on that score. Please, anybody else got any thoughts they'd like to like to put to Andy while we've got him, because it's such a great pleasure to have you here, Andy. And
I think Ian is trying to say something, Nick.
Oh, he's not using the blue hand raise. Ian waving, not drowning. Good evening, Ian.
Hi. Good evening, Andy, as well. So interested in what you're talking about around data, the data acquisition, data usage, and how you're using it. And it's an area I work in quite a lot. But a lot of my expertise has been in the pharmaceutical industry and working around PAT and QBD, if you've come across these.
Yeah.
And a lot of the work we've done has actually been on soft sensors. So, and this is where the question really is how much data are you expecting to get out of your sensors, and what are you expecting to augment that with?
Well, that's a great question, because I think that's still a bit of an unknown for us. I mean, what we're hoping to get from the sensors is, well, some data which will be an indirect measure. You know, we're not going to be, so if you measure microbiology today, it's typically colony forming units and you count them. We're not going to have that. So we're going to be measuring indirect techniques, whether it's, you know, some of them are based on optical, but some of them are based on electrical, some of them are based on conductivity, you know, that type of thing. And of course, as I mentioned earlier, microbiology doesn't change that often. So it's a good question in terms of how much data do I need to collect before I see a change. That is still one of our big challenges to solve, but you know, and we haven't cracked that one yet. But and I appreciate what we don't want is be collecting lots and lots of data, filling up lots of databases and storage facilities, and then we can't actually do anything with it. So we probably are going to have to filter that somewhat. But in terms of what are we going to augment it with? Well, we're going to augment it with a lot of the raw material data, as well as the inline process data, so that we can, and that's where the AI really is going to come in, so that we can understand what is changing in the process or in the raw materials, which somehow influences, you know, what's happening in the microsensors. And how we kind of piece that together across the end-to-end supply chain is still, one of the big unknowns that we need to crack. I don't think we're going to crack it in the 6-month feasibility study, but in the 2-year, we definitely need to crack that one.
And another little question on the side here is, have you thought of capturing human knowledge around this as well?
We haven't, but that's a very interesting idea. Say some more.
So a lot of what we do uses 2 elements. It uses data, so we model around real-time data, but we can bring in mechanistic and first principle models, but we also capture knowledge from experts. So we can create, basically, if you like, almost a process bot by taking people's understanding and applying that, and then applying it to the data as well. So you get a multi-dimensional layer there.
That's a very interesting idea.
Just one of the advantages of that is it can actually end up reducing your compute power to get results from sensors.
Very smart. Yeah, no, that sounds like a great idea. Okay. Well, maybe we should connect offline, perhaps.
Yeah, I was going to say, I'll drop you an email.
Yeah.
Thank you.
No, thank you, Ian. That's great.
Steve, hi.
No, just to say, Andy, is that there are already solutions out there for moving data around that collect data from like thousands of sensors and multiple factories, and there are already sort of protocols for doing that and moving all that data into a central control panel, and people in that central control panel say, you know, there's something gone wrong over on the far left there, mate. Go and hit it with a hammer. That stuff is I don't think it's that mature, but it's mature enough to be able. I mean, and I'll put you in contact with somebody. But I think it's not quite. There's a wheel there already. Simply bolt it to the axle. But a lot of the structure people are working with and have been doing for quite a few years.
Okay.
And it's get more success lately.
Okay, oh, that's great, Steve. Thank you very much.
Cheers.
Andy, am I at liberty to share this Argus document?
You can, because that's the public-facing statement that we've shared, that's out in the public domain. I know I've shared it with you and Ram already before, so yeah, I'm more than okay that you share that broadly. Yeah, that's fine.
Okay, super. I'll send that out to the members participating here today. In fact, I might send it out to the whole group and see what happens, because this has been an absolutely super conversation, and I'm so pleased to see that. Yeah, I'm not surprised, but I'm just pleased to see that we've actually been able to raise your eyebrows, which I think says something about Kaizen Central and bears out exactly what Ram said. This is the center of the known universe of manufacturing knowledge. But there we go. I just want, we've got a few minutes left. Unless anybody's got any more questions or thoughts for Andy. I just wanted to brief you very, very quickly about the development of the UK MFG Unite website, which I think you all know we took over quite recently. We have now got everything. It's always a bit of a pain going through that process, but now we are owners and administrators of the UK Manufacturing Unite website, which has close to 400 members, many of them here with us this evening. It was started, pardon me, as you know, at the start of the pandemic as a way for manufacturers to interact with each other, support each other, look for help, offer help. And as time went on, the guys running it were, that wasn't their day job to manage a community. We've taken it on with a significant amount of ambition for it, and it will become the vehicle by which we convey the mission that we've spelled out before, as we the shortened version of it is our BHAG, our big, hairy, audacious goal. But we have lots of ideas around it. I will be sending you out some thoughts quite soon around what we're going to do with this in the long term. And it's going to take us a good few weeks and quite a lot of cash to make it happen. So, where we sit at the moment, we're going to have to get from here to there, crawling over a little bit of broken glass. But I think that when we share the vision, I think it would excite everybody. And I guess my request to you, when you do hear from me about it, is please go out and excite other people about it, so that we can indeed raise the amount of money we need to make it happen. Because I, for one, too many sleepless nights. I'm so excited by this. So I'll share it with you next week, and then we can perhaps have a few discussions offline. But that will be UK Manufacturing Unite, UK MFG Unite, UK MFG TV. So there we are. There is a lovely confluence of ideas and synergy there. So bless you all. Thank you very much indeed for being with us this evening. Andy Dorset, what a great pleasure to see you here. Ram, thank you very much indeed for bringing him to the party. Andy, that link I sent you, if at any time you just want to drop in and say hello on a Thursday evening at 6 o'clock, that link is valid. So, just come in any old time. That'd be great to see you. Anybody who's on the call who we haven't seen before, please drop me a note or an email, just so we can keep in touch, and I can add you to our weekly chat. Anyway, thank you very much, everybody. Andy Dorset, terrific. Everybody on tonight, I really appreciate you coming. We'll see you next time. Goodbye, everybody.
Goodbye.